Here are the answers to the Surds questions on pastpaperpenguin.com. Now, pretty much all of these should be done without a calculator, so you can expect them to come up on a non-calculator paper. This first question here wants us to rationalise the denominator. That means we want the bottom, the denominator, to be a rational number. To achieve that, we're going to multiply top and bottom by root 3. On the top, 2 times root 3, we're just going to write as root 3. On the bottom, square root of 3 times the square root of 3 is root 9, or we can just write that as 3. So there we go, we have made the bottom rational, so that's the first one done. The second one is a bit trickier and more likely to be like the kind of question you get. When you get two terms on the bottom like this, the thing we always want to do is multiply by the conjugate of the bottom. Now that means instead of root 5 plus 1, we're going to multiply by root 5 minus 1 on both the top and the bottom. That's going to be our first step in lots of these questions. Okay, so let's just write that out with our brackets in place. On the bottom we get root 5 plus 1, root 5 minus 1. The top we can expand out. We get 2 root 5 minus, and 2 times 1 is 2. And on the bottom we're going to do first outsides, insides, lasts. Root 5 times root 5 is root 25, or we can just write that as 5. Root 5 times minus 1 is minus root 5. Root 5 times plus 1 is plus root 5. And then plus 1 times minus 1 is minus 1. And kind of the whole point of that was for this thing here to happen. These two middle terms, minus root 5 and plus root 5, cancel out. So on the top, I just get 2 root 5 minus 2. And on the bottom, I'm just left with 5 take away 1, which is 4. So you can see we've rationalised the bottom as required. Now the thing that a lot of people then forget is that we can actually simplify here. We can divide this by 2, this by 2, and this by 2. So let's go ahead and do that. We get root 5 minus 1, all divided by 2. Don't forget that step there. This question wants us to square this expression with surds. I think the safest way to do that is to write the bracket out twice. And then we'll do our usual firsts, outsides, insides, lasts. So multiplying the first terms, 5 times 5 is 25. Outsides, 5 times 2 root 3 is 10 root 3. And the insides, 10 root 3 again. And then for the last, 2 times 2 is 4. And root 3 times root 3 is 3, root 9 or 3. So 25 plus, and now 10 root 3 add 10 root 3 is 20 root 3. And 4 times 3 is 12. Now let's just add those two things together. 25 add 12 is 37 plus 20 root 3. This next question is another one where we need to rationalise the denominator, and we have a binomial on the bottom. Excuse me. So once again, we're going to multiply by the conjugate by 2 minus root 3. Let's write that, what that looks like. So 5 brackets 2 minus root 3. And on the bottom, 2 plus root 3, 2 minus root 3. So on the top, 5 times 2 is 10, minus, and 5 times root 3, we just have to write as 5 root 3. And on the bottom, first, outsides, insides, last, so 2 times 2 is 4. Outsides, we get minus 2 root 3. Insides, we get plus 2 root 3. And then for the last terms, root 3 times root 3 is root 9, or just 3. Okay, so the top, still 10 minus 5 root 3. The bottom, once again, those two middle terms cancel out. If they didn't, we've done something wrong. And we're left with 4 subtract 3, which is just 1. And let's not leave it like that with the 1 on the bottom. We're just going to write 10 minus 5 root 3. To simplify these surds, we need to look for the biggest square number that is a factor of each of these. So here, first of all, in root 32, well, the biggest square number, there's one that's bigger than 4. The one that's bigger than 4 is 16. So I'm going to write that as root 16 times root 2. So that's the same as root 32. This one here, the biggest possible square number, well, actually, the only one I can think of is the square root of 49 times root 2. Okay, so root 16, well, that's 4. So this one here is 4 root 2. And root 49, that's 7. So we're left with 4 root 2 plus 7 root 2. And those two things we can add up. It's like having 4x add 7x and adding them up. So 4 root 2 plus 7 root 2 is 11 root 2. Here's another rationalise the denominator. Once again, our first step is to times by the conjugate, so root 2 minus 1, top and bottom. So on the top, we're just going to get root 2 minus 1, because it's 1 times by that. And on the bottom, let's write it out first with the 2 brackets. And then once again, we're going to do first outsides, insides and lasts. So root 2 times root 2 is 2. Root 2 times minus 1 minus root 2. Root 2 times plus 1 is plus root 2. And 1 times minus 1 is minus 1. Once again, the middle terms cancel out. So I get root 2 minus 1 over 2 take away 1. Now 2 take away 1 is just 1. So we get root 2 subtract 1. Another simplified question here. Let's look for the biggest square number that's a factor of each of these. So biggest square number that's a factor of 50 is square root 25. So we can write root 25 times root 2. This one here, I think it's got to be 4. So root 4 times root 2. Root 25 is 5. So this one is 5 root 2. And root 4 is 2, so that's 2 root 2. And now we can subtract. 5 root 2 subtract 2 root 2 is 3 root 2. To rationalise the denominator, we need to multiply by the conjugate once again, even when they're both square roots. So I'm multiplying top and bottom by root 7 plus root 3. Let's write down the top, so we've got 12 brackets root 7 plus root 3. And on the bottom, root 7 minus root 3 times root 7 plus root 3. The top's not going to look very nice for now. We're going to write 12 root 7 plus 12 root 3. On the bottom, root 7 times root 7 is root 49, or just 7. That's the first terms. Now the outsides ones, root 7 times root 3, we can write that as plus root 21. The insides, minus root 21, and the lasts, minus, and then root 3 times root 3 is root 9, or just 3. Again, the two middle ones cancel out. So I get 12 root 7 plus 12 root 3, all divided by 7, take away 3, which is 4. Don't forget, check that we can't simplify, and we can here. We're going to divide everything by 4. So 12 divided by 4 is 3, so I'm going to get 3 root 7 plus 3 root 3 by dividing that, that and that all by 4. Already we're starting to see questions repeat themselves, so we're going to simplify this root 98. Biggest square number that goes into 98 is 49. So root 49 times root 2. Root 49 is 7, so that there is just 7 root 2. To rationalise the denominator, again, we're going to multiply by the conjugate. This time it's minus in the middle, so I'm going to change it to a plus. And that's going to be on the top and the bottom. Whoops, I meant to write root 5 there. Let's do that again. So on the top, 3 brackets root 5 plus 2. And on the bottom, root 5 minus 2 times root 5 plus 2. If we expand the top, we get 3 root 5, and then 3 times 2 is 6. On the bottom, root 5 times root 5 is root 25, or just 5. The outsides, plus 2 root 5. The insides, minus 2 root 5. And then minus 2 times 2, which is 4. The middle terms disappear. So we get 3 root 5 plus 6 on the top. And on the bottom, 5 take away 4 is 1. So that's 3 root 5 plus 6. Okay, we've got 3 surds that we need to add or subtract. So first of all, look for a square number that goes into root 27. Well, that's going to be root 9 times root 3. Plus, and the biggest square number that goes into 12 is 4, so root 4 times root 3. And presumably this is going to be something that has root 3 in. So all I'm thinking now is let's divide 108 by 3, and what do we get? What is that, 36? Yeah, 3 36's make 108, so that's going to be root 36 times root 3. Root 9 is 3, so this first one is 3 root 3, plus root 4 is 2, so 2 root 3, and root 36 is 6, so minus 6 root 3. 3 root 3 plus 2 root 3 is 5 root 3. Subtract 6 root 3 gives me minus 1 root 3, or just minus root 3. To rationalise the denominator, we're going to multiply by the conjugate again, so we're multiplying top and bottom by 3 plus root 5. So on the top, 2 brackets, 3 plus root 5. And on the bottom, 3 minus root 5 times 3 plus root 5. 2 times 3 is 6. And 2 times root 5 is just 2 root 5. On the bottom, 3 times 3 is 9, doing the first terms. The outside ones plus 3 root 5. The inside ones minus 3 root 5. And the last minus and root 5 times root 5 is root 25, or just 5. So on the top, 6 plus 2 root 5. Those two middle terms cancel out again. And we're left with 9 minus 5 on the bottom, which is 4. We can divide each of these terms by 2, and if I do that, I get 3 plus 1 root 5, or just root 5, divided by 2. Again, we're simplifying, so we're looking for square numbers going into each of these. The biggest one I can think of that goes into 75 is 25, so I'm going to write root 25 times root 3. Presumably root 3 is going to go into all of these. Now if I divide this one by 3, I get 16, so that's root 16 times root 3. And this one is root 4 times root 3. Root 25 is 5, so the first one is 5 root 3 minus 4 root 3 plus 2 root 3. 5 root 3 minus 4 root 3 is just 1 root 3. And root 3 plus 2 root 3 is 3 root 3. In the second part, as is becoming quite common, we're rationalising the denominator, so we're going to multiply by the conjugate, root 3 minus 5, top and bottom. On the top it's just 1 times by that, so we're just going to get root 3 minus 5 on the top. On the bottom, let's write it out with the brackets and then do first outsides, insides, lasts. Root 3 times root 3 is root 9, or just 3. The outsides we get minus 5 root 3, the insides plus 5 root 3, and then the lasts minus 25. So on the top, root 3 minus 5. On the bottom, the two middle terms cancel out again, and we get 3 minus 25, which is minus 22. Now, we don't really like having negatives on the bottom of the fraction, what we usually do if we have just one number that's negative on the bottom of the fraction like that, is we multiply top and bottom by -1. If I do that, I get minus root 3 plus 5 over 22, and then just to make it a little bit neater, I'm going to put the 5 first. So 5 minus root 3 over 22. That's probably the neatest way to write that one. This question is similar to ones we've done before, but they're doing it algebraically. We're going to do the same thing, and we're going to do first outsides, insides, lasts. So we'll do the firsts to begin with. Root a times root a we can write as root a squared. It simplifies, but we'll do that in a second. And these are both under the square root, so we can multiply them together. We've got a positive times a negative, so it's negative. And root a times root b is just root ab. We can write it like that. Now the insides, positive times a positive, and it's root b times root a, so that is going to be the same thing underneath there, root ab again. And then positive times a negative, so it's negative root b squared. Okay, these two middle ones are going to cancel out again. So I'm left with root a squared. Now the square root of a squared is just going to be a, and the square root of b squared is just going to be b. So this whole thing just simplifies to a minus b. Part B is another rationalise the denominator. Once again, we are going to multiply by the conjugate, root 7 minus root 6, both on the top and the bottom. Because we're multiplying by 1 on the top, it's just going to be root 7 minus root 6. On the bottom, we get root 7 plus root 6 times root 7 minus root 6. Now, on the bottom, we're going to do first outsides, insides last. So root 7 times root 7 is root 49, which is just 7. Outsides, root 7 times root 6 is minus root 42. Insides, plus root 42. And then the lasts, plus root 6 times minus root 6 is minus root 36, or just 6. Those middle terms cancel out again. So we get root 7 minus root 6, all divided by, and 7 take away 6 is just 1. So that is just root 7 minus root 6. This part C here looks a lot trickier than it actually is, and I think it's really important to look at the question above and see the similarities with what we've got there. And you can see we've already worked out one of these things. 1 over root 7 plus root 6. When we rationalised the denominator, we found out that that was just equal to root 7 minus root 6. You could probably have a pretty good guess as to what all of these other ones are going to be. They all have a difference of 1. I'll just show you one of the other ones just to convince you that we're going to get a really similar result here. Okay, and it's because they're all 1 apart. Root 9 and root 8 are just 1 apart, same with root 8 and root 7. Let's see what happens if we rationalise the denominator. Now, I don't think you'd have to do this to justify your answer. I'm doing it to show you how it works. So on the top, I'm going to get 1 times root 9 minus root 8. On the bottom, we'll do first outsides, insides last. So root 9 times root 9 is root 81, or just 9. Outsides, root 9 times root 8, we get minus root 72. The insides, plus root 72. And the lasts, minus root 8 times root 8, which is root 64, or just 8. So on the top, we get root 9 minus root 8. On the bottom, those middle ones cancel out, and we're just left with 9 take away 8, which is 1. So look, that first one, as you can see, also gives me root 9 minus root 8. So all of these are going to work a really similar way. So instead of actually working them all out, and I don't think they expect us to do that, I think they expect us to spot that pattern and just to say, well, This one here is going to be equal to root 9 minus root 8. This next one here is going to be equal to plus root 8 minus root 7. The third one, plus root 7 minus root 6. Next one, plus root 6 minus root 5. And the last one, plus root 5 minus root 4. And something really interesting has happened here. We've got minus root 8 and plus root 8, they cancel out. Minus root 7 and plus root 7 cancel out, and so do the two root 6's and the root 5's. And the only ones we're left with are root 9 minus root 4. Root 9 is 3. Root 4 is 2. So that's 3 take away 2. So the answer to all of that thing is just 1. More standard question next. Again, times in by the conjugate. Root 7 plus 2, both the top and the bottom. On the top, 9 brackets root 7 plus 2. Whoops. Let's do that again. Root 7 plus 2. And on the bottom, root 7 minus 2 times root 7 plus 2. So on the top we get 9 root 7 plus 18, expanding those brackets. On the bottom, root 7 times root 7 is root 49, or 7. Outsides we get 2 root 7, insides we get minus 2 root 7, and lasts minus 2 times plus 2 is minus 4. The middle terms cancel out again on the bottom, and on the top we get 9 root 7 plus 18. And on the bottom, 7 subtract 4 is 3. All of these things are divisible by 3, so let's do that. We get 3 root 7 plus 6, all divided by 1, or just 3 root 7 plus 6. This question just wants us to expand and simplify these two binomials here. So we're going to do first outsides, insides, and lasts. So first, 2 root 3 times by 4, well 2 times 4 is 8, so that's 8 root 3. 2 root 3 times by root 3, well that's going to be 2 root 9, we'll simplify that in a moment. The insides we've got minus 5 times 4, that's minus 20. And then the lasts, minus 5 times positive root 3 is minus 5 root 3. So here, like I said, this square root of 9, that's 3. So here we've got 2 times 3, which is 6. Minus 20, minus 5 root 3. And now we're going to collect together the 8 root 3 and the minus 5 root 3. So that one and that one. 8 root 3 minus 5 root 3 is 3 root 3. And positive 6 subtract 20 is minus 14. So 3 root 3 minus 14. Here we've got a rationalising the denominator, which is slightly more difficult than usual because instead of just having root 2, we've got like 2 root 2. But the principle's just the same. We're going to multiply top and bottom by the conjugate. This time that's 2 root 2 plus 1. Okay, so on the top we've got 3 brackets 2 root 2 plus 1. And on the bottom, let's just straighten it up a bit. And on the bottom, let's put both brackets here. So 2 root 2 minus 1, 2 root 2 plus 1. We'll expand the top first. 3 times 2 root 2 is 6 root 2. And then 3 times 1 is just 3. On the bottom, 2 root 2 times 2 root 2, well that's 4 root 4, we'll simplify that in a moment. The outsides, that's plus 2 root 2. The insides, that's minus 2 root 2. And then the lasts, minus 1 times positive 1 is minus 1. Those two middle terms cancel out as usual. Okay, so on the top we've got 6 root 2 plus 3. And on the bottom, well, this root 4 is 2. So here on the left here we've got 4 times 2, which is 8. And then subtract 1, which is 7, so we get 6 root 2 plus 3 all over 7. I just did a quick double check in my head there because these are both divisible by 3, so I expected something divisible by 3 on the bottom, but it's not. I don't think we've made a mistake anywhere. I think that's okay. Another rationalise the denominator question. Let's times by the conjugate, so times by root 5 plus 1 on the top and the bottom. So that would be root 5 bracket root 5 plus 1. And on the bottom, our two brackets are root 5 minus 1 times root 5 plus 1. On the top, root 5 times root 5 is root 25. And then plus 1 times root 5, well, that's just root 5. On the bottom, root 5 times root 5, well, again, is root 25. Then the outsides, we get plus root 5. Then the insides, minus root 5. And then the lasts, minus 1 times positive 1 is minus 1. So root 25 is 5, so that first term there we get 5 plus root 5. Those two middle terms cancel out as always. On the bottom here, again, we get 5, and then subtract 1. So just simplify that at the bottom there. The denominator, 5 plus root 5 on the top, and 4 on the bottom. This is another one where we need to just expand. So once again, we're going to do firsts, outsides, insides, lasts. So first we'll do 4 times 5, that's 20. Then the outsides, that's 4 times negative root 3, so that's minus 4 root 3. Then the insides, 2 root 3 times 5, well that's plus 10 root 3. We can multiply the 2 with the 5, but not with the square root. And then positive times a negative is negative, and 2 root 3 times root 3 is 2 root 9. We'll simplify that in a moment. In fact, we'll simplify it right away here. 20 minus 4 root 3 plus 10 root 3, and root 9 is 3, so that says 2 times 3, so that's 6. Okay, so now we're going to collect together the 20 and the minus 6, that gives me 14, and minus 4 root 3 plus 10 root 3 is plus 6 root 3. So 14 plus 6 root 3. This question's a bit of a strange one. Now, it may not look like a Surds question, but it actually is. And the first thing I'd ask you to do, if you've not already managed it, is try and simplify both of these Surds. And when you do, you should find that you get some expression in terms of one of these. Okay, so try that now if you haven't done already. If you try to do that, what you'll have found when you try to simplify this Surd is this one here. We can do root 100 times by root 7. Okay, that's the biggest square number that goes into 700. 10 is not a square number, so no use dividing this one by 10 and taking square root 10 out. That's why we're using square root 100 here. So that thing here gives me 10 root 7. And now I'm going to use this one up here. It's telling me that root 7 is 2.65. So I'm going to do 10 times 2.65, which is 26.5. Similar thing with this one. Well, this time I think the biggest square number we can take out is going to be 4. Root 4 times root 70. And you can see we're using the other one. Well, root 4 is 2, so that is the same as 2 root 70. So for this one I'm going to do 2 times 8.37. So 2 times 7, 14, 2 times 3, 6, that one's 7. So 16.74. Here once again we're going to multiply by the conjugate. Both of them are square roots this time. So we've got root 3 plus root 2, and on the bottom root 3 plus root 2 as well. Oops. So on the top 5 brackets root 3 plus root 2 And on the bottom, root 3 minus root 2 times root 3 plus root 2. On the top, 5 times root 3 is 5 root 3 plus 5 root 2. And on the bottom, as always, we're going to do first outsides, insides and lasts. Root 3 times root 3 is root 9. Outsides, root 3 times positive root 2 is root 6. Insides, minus root 6. And lasts, positive times a negative is negative. Root 2 times root 2 is root 4. So still on the top, 5 root 3 plus 5 root 2. On the bottom, well, those two middle terms cancel out as always. Square root of 9 is 3. Square root of 4 is 2, so that's minus 2. So on the bottom we just get 1, so we've got 5 root 3 plus 5 root 2 over 1. So we're just going to write 5 root 3 plus 5 root 2. Bit different this question, it gives us a right angle triangle. So straight away with this right angle triangle, hopefully what you're thinking is we're going to do Pythagoras. So let's do the two shorter sides squared, so x squared plus, and I think it's really important at this stage to put this thing in brackets, 2 root 3 all squared. Otherwise, if you don't have those brackets, the only thing you'd be squaring is the root 3. We want to square the whole number, including the 2 as well. So we've got x plus 2 root 3 all squared equals, and again this one needs to be in brackets, 5 plus root 3 all squared. When I square this one, well, I'm going to square the 2, that's 4, and square the root 3, that's square root of 9. For this one here, maybe we'll write it as two brackets first of all. That means 5 plus root 3 times 5 plus root 3, and we're going to do first, outsides, insides, lasts, as we always do. On the left hand side, square root of 9 is 3, so this says 4 times 3, which is 12. And here, the firsts, well, 5 times 5 is 25. Outsides, 5 times root 3 is 5 root 3. Insides, same thing, 5 root 3. And then the lasts, root 3 times root 3 is root 9. So I've got x squared plus 12 equals 25. Let's collect those two middle terms. 5 root 3 plus 5 root 3 is 10 root 3. And here the square root of 9 is just 3. So I've got x squared plus 12. Let's collect the 25 and the 3 together. So 28. And now, only thing we need to do is subtract that 12 from both sides. So 28 take away 12 is 16 plus 10 root 3. And notice it asks for x squared. We don't need to square root it. We're just going to leave it like that. A pretty straightforward simplifying question here. The biggest square number that goes into 125 is 25. So let's write that as root 25 times root 5. Careful here. There's a bigger square number than 4 that goes into this 80, and that bigger square number is 16. I'm going to do root 16 times root 5. Root 25 is 5, so here I get 5 root 5. Root 16 is 4, so here I get 4 root 5. Now I can add these two things up. 4 root 5 plus 5 root 5 plus 4 root 5 is 9 root 5. Another simplifying one. This time we've got root 75. The biggest square number that goes into that is again 25. So root 25 times root 3 is root 75. And the biggest square number that goes into 27 is 9. So that's root 9 times by root 3. Root 25 is 5, so the first one is just 5 root 3. Root 9 is 3, so that one is 3 root 3. And then we've got 5 root 3 minus 3 root 3, which is 2 root 3. For part B, we're rationalising the denominator again, so as always, multiply by the conjugate, 5 plus root 5 on the top and on the bottom. So on the top we get 10 brackets 5 plus root 5, and on the bottom 5 minus root 5 times 5 plus root 5. So let's expand the brackets on the top. 10 times 5 is 50, plus 10 times root 5 we write as 10 root 5. On the bottom, first outsides, insides last, so 5 times 5 is 25. Outsides, we get 5 root 5. Insides, minus 5 root 5. And then the lasts, minus root 5 times positive root 5 is minus root 25. Those two middle terms cancel out. So on the top we get 50 plus 10 root 5. And on the bottom we get 25. And root 25 is 5, so it's 25 subtract 5. There is going to be a bit of simplifying this time on this one. 50 plus 10 root 5 on the top. On the bottom, 25 take away 5 is 20. And we can divide everything by 10, all of these terms by 10. And if I do that, I get 5. Let's write this straight on the answer line. 5 plus 1 root 5, or 5 plus root 5, all divided by 2. This is another straightforward expansion question. The only thing that you've got to watch out for is to make sure that you write it maybe like this first, so that you don't accidentally just square each of the terms. We've got to do first, outsides, insides, lasts. Okay, so first we're going to do 2 root 3 times 2 root 3. That's 4 root 9. Then we'll do our outsides. So positive times a negative is a negative. 2 times 3 is 6. Root 3 times root 2 is root 6. Then we'll do the insides. Positive times a negative is negative again. 3 times 2 is 6. Root 2 times root 3 is root 6. And then our lasts. Negative times a negative is positive. 3 times 3 is 9. Root 2 times root 2 is root 4. Now let's simplify what we can. Square root of 9 is 3, so this first term is 4 times 3, which is 12. Minus 6 root 6, minus 6 root 6, plus, and this one here, root 4 is 2, so this is 9 times 2, so this is 18. Now the only thing we need to do is collect the two middle terms and the outside ones as well. Let's start with that. 12 plus 18, that makes 30. Minus 6 root 6 minus 6 root 6 is minus 12 root 6. So there we go, we've got it in that form where P is 30 and Q, careful, it says plus Q here, so our Q is going to be minus 12.